Hello, my name is Xander Fernald, and this is my long demo of my UCR CS122A custom project, the Retro Game Emulator. Retro Game Emulator is made from a Raspberry Pi 0WH, which is right in here. It's also made with a custom hardware kit, including a PCB, a LCD screen. I believe the resolution on it is 288 by 320. It includes a speaker, a battery, safely housed in here, 3.7 volt LiPo 2000 milliamp hour battery, the full kit of buttons, and I believe that is it. I don't think I'm forgetting anything. Oh, the case was sold separately. The case is an actual Nintendo Game Boy Advance case, made for a real Nintendo Game Boy Advance that's been modified to fit the hardware inside. I've had 2 extra holes drilled for the 2 extra buttons, and a lot of the internals had to be cut to make space for the PCB. The Retro Game Emulator runs RetroPie as the Raspbian image for the Raspberry Pi. This allows it to emulate most old retro game systems, including Game Boy, old Nintendo home systems like the 64, the NES, the SNES. It allows it to emulate Sega Genesis, even old PlayStation games, depending on the strength of your Raspberry Pi. They're not all going to play well. Anyways, I'll boot up the system here real quick. The ROMs for the system are imported through a USB stick. The USB stick has a USB-A to micro USB adapter, which plugs into the Raspberry Pi's data port, and RetroPie handles the rest when it comes to downloading the ROMs and putting them onto the right emulators. The system's rechargeable. It has roughly a 5-hour battery life, or so I've seen on the internet based on people who've made similar builds with similar batteries. Haven't fully tested the 5-hour battery life myself, but I've only had to charge it once since I've made it, so I believe it. It recharges with a micro USB cable through this port on the PCB. So now that this is loaded up, I have my emulators here. I have Game Boy, Game Boy Advance, Game Boy Color, and Nintendo 64, as these are all of the ROMs that I have added to here so far. The Game Boy portion is all ROMs that I have personally programmed. These ROMs are testing basic functionalities of Game Boy programming, just very basic things like importing sprites, doing a little bit of player movement, changing sprites, adding backgrounds, having sprite and background interactions such as collision detection, adding words on screen, text either through a simple printf or through the actual HUD layer of the Game Boy screen, and some elements that move on their own, such as the scrolling background or the initial sprite test, which the sprite moves on its own. So I will go through these. The first ROM that I ever made was the Hello World ROM, very basic, but this was a very big breakthrough for me because it was the first instance of being able to program C code into a Game Boy ROM, which is importable on this device. As you can see up in that top corner, it just says Hello World. That's all this does. But this was the first step in being able to program these ROMs and write C code that I could translate to something that I could put onto this device. So I'm going to toggle the power switch. What that does is it's like the activation hotkey for RetroPie, and then press the start button to exit the ROM. The second one that I did, there's a couple throwaways in here like main, and the sprite movement test was replaced with sprite movement test 2. But then the next one that I tested was the sprite test, testing some very, very basic sprites that move on their own without any player input. Wait for this to launch. There he is. Little happy face, moves back and forward, and his mouth changes. That's it. Just a small loop that loads in a sprite, then every tick it'll move its location, change the sprite from either the flat face to the smiley face, and then delay for a certain amount of time. Very basic next step, but this ROM required use of some outside tools aside from just the Game Boy Developer Kit, which allowed me to compile my C code into a Game Boy ROM. It required that I use the program Game Boy Tile Designer. The Tile Designer lets you draw sprites in an 8x8 pixelated grid with 4 gradients of color, because this is for the Game Boy before they had color. And you can import, or you can export those tiles into your C code as a header file, and it shows up as an array of hex values referencing your tiles. That's about all for this ROM. I will exit this now. And the next logical step was to allow you to move your own sprite. So then that one, I have the sprite movement test number 2. I'll allow this to boot up. So this little guy can move around whenever I move him on the D-pad. It's the same little face from the other one, and actually I added a feature where you can press the A button to toggle him from happy to flat, and you can move him around with the D-pad. This was an extremely basic function. It uses a built-in function to the Game Boy Developer Kit called the joypad function, which detects input from here and saves it as, oh, as you can see there, he can move off the screen, as I haven't inputted collision yet in this one, or boundaries. But yes, it takes input from the system and basically detects your input and sets it as a variable, which you can check against for things like moving the sprite or doing an action like changing the sprite. So that's about it for this ROM. Oops. Next, I implemented the scrolling background, but the HUD test actually has the exact same scrolling background in it, so I'll do 2 for 1 on this one, save a little tiny bit of time. On this one, there's a scrolling background of a brick wall and a little spot underneath called Hello World. In Game Boy programming, there are generally 3 layers to the screen. There's the background layer, the sprite layer, and then the HUD layer. The HUD layer and the background layer sometimes are seen as the same layer, though, because technically they share the same sprite space. It's hard to see, but as you can see, a little bit above the Hello World, it's a little bit fuzzy. It's like grayed out, and where the Hello World is, it is not. It's supposed to be grayed out all the way to the bottom of the screen, but the Hello World is taking up that spot and overwriting it. So it does conflict with the background layer a little bit. The Game Boy tile designer played a part here in allowing me to draw the tiles for the brick wall and for the ground, but the tiles had to be exported in addition to my C code, to the Game Boy map builder to be drawn into a background map like this. The background map can be drawn from the tiles that you make in the tile designer, and then exported to your C code as a header file as well. And again, this is stored as an array of hex values, which reference different tiles. So that's about it for this. And that all culminates in my maze game. Maze game I demoed in my shorter video. Basically, the function of it is you have your character who spawns in the bottom right-hand corner of the screen, and you have this maze of rocks. And in the maze, there are 3 stars. And your job is to go through the maze and collect the stars. Once you have collected all of the stars, you win the game. This ROM implements basically every feature that I have previously tested for this emulator. It implements a couple new features too. It implements collision detection. It implements obviously the player movement, using both sprites and backgrounds. Interacting between sprites and the backgrounds, another new feature. Displaying text on the screen. And it implements sprite switching too. It's a little hard to see, but when you move left, he looks left, and when you move right, he looks right. Just a fun little detail that I put in there just for me. So I believe that this ROM is the culmination of everything that I've learned throughout this project. This project was extremely fun for me. I've always loved Game Boy games, and I've always wanted to know what really goes on under the hood for this sort of a thing, and I think this project was the perfect way to dip my toes into that area, and I'm really happy with how it turned out. This has been my long demo for my CS122A Intermediate Embedded Systems custom project, and yeah, that's it.